right, so this is a continuation of section 7.3. This is part 2. And it's just going to have 2 examples, but they're actually application problems. It shows you where you use logarithms. Okay, so at the very top of this page, it talks about a common logarithm with base 10. So here it tells you that you can write a common logarithm, log base 10 of x, as just the log of x. If it is base 10, you do not have to write the 10. And these next 2 problems are going to be log base 10 problems. Okay, so in problem 3, it says, in December 2004, an earthquake with magnitude 9.3 on the Richter scale hit off the northwest coast of Sumatra. The diagram shows the magnitude of an earthquake that hit Sumatra in March 2005. And I'm going to make that note over here. So March 2005 from the diagram was an 8.7 on the Richter scale. And then in the very first sentence, they told me about December 2004. The one that hit was a 9.3. Okay, so now let's keep reading. The formula, here it is. The log of I sub 1 over I sub 2 equals m sub 1 minus m sub 2. It compares the intensity levels of earthquakes where I is the intensity level determined by a seismograph and m is the magnitude on a Richter scale. How many times more intense was the December earthquake than the March earthquake? Okay, and I actually like this problem. It's kind of neat because it told me a whole lot about earthquakes that I did not know. I have no frame of reference for earthquakes, and 8.7 and 9.3, they both sound really bad to me. I don't want to be there. But until I worked this problem the very first time I, taught out of this book, I had no idea how much worse a 9.3 was. Okay, and for those of you who've lived around here for a while, you understand the difference in, the scale they use to measure tornadoes. An EF3, an EF4, an EF5. You know that, an EF5 is just like the worst ever, and an EF3, it doesn't sound like there's a whole lot of difference because it's only 2 numbers away, but it is a huge difference. So that's the only thing I can compare this to. I have a frame of reference for tornadoes. I had no frame of reference for earthquakes, but this problem gives me one a little bit. So what we're going to do is we're going to work this problem. I'm going to do the log of I sub 1 over I sub 2, and then I'm going to do the magnitude of the first one, which occurred in 2004, minus the magnitude of the second one, which occurred in March 2005. So what I want you to remember while you're working this problem is that this is a base 10. Okay, the formula does not have a base for the logarithm, so it is understood to be a base 10. So now, as we work this problem, I'm going to have log base 10, I sub 1 over I sub 2, and then when I actually subtract over here, I end up with 0.6. And what we're going to do at this point is we're going to change to exponent form. So to do that, remember, you're going to bring this I sub 1 over I sub 2 straight down, and then on the other side, you're going to do 10 to the 0.6 power. And now I'm just going to type that in my calculator, and I'm just going to round it to a whole number. So 10 to the 0.6 power is approximately 4. So what that tells me is that the earthquake in December 2004 is 4 times more intense than the March 2005 earthquake. Okay, and again, I had no idea that, this 9.3 caused 4 times the amount of damage, the number of lives lost, economic, having to rebuild, all of that, 4 times more for a 9.3 than for an 8.7. So this problem gives me a little bit of a frame of reference for that. So now what we're going to do is go down here to the got it question and let you try one. We're going to use the exact same formula we did in the last one, because this is the formula that compares the intensities of one earthquake to another. Okay, and once again, remember this is a base 10. So you may want to pause it here while you finish working this one. See if you can do it on your own. And then once you've finished it, come back, hit play again, and see how you did. All right, so what I'm going to do is start plugging things in. And so now when I subtract 8 minus 6.8, that's going to give me 1.2. And then I'm going to change that to exponential form. I need more room, so I'm going to put it up here. So I sub 1 over I sub 2 equals 10 to the 1.2 power. So the intensity of the first compared to the intensity of the second is about 16 times more intense. So here's what it's telling me. The earthquake in 1995 was 16 times more intense than the 2001. All right, so that brings us to the end of these two examples, and that's video 2 of 3 for section 7.3.